In this video, we're going to give an introduction to ions. So atoms will have the same number of protons as they do electrons. So in other words, for every positively charged proton that an atom has in its nucleus, it will also have a negatively charged electron around the nucleus. So since atoms have the same number of positive and negative charges, we can say that they are neutral, or we could say that they have a net zero charge. Now they do have positive and negative charges, but they have a net zero charge because the sum of the positive and negative charges is equal to zero. Ions, however, are atoms that have gained or lost electrons. So in order to gain or lose electrons, the atoms must undergo some chemical reaction or chemical change. When atoms gain or lose electrons, the number of protons never changes. So they can gain or lose electrons, but the protons for that atom is always constant. So the number of protons and electrons are no longer equal. That gives the atom or the ion a net charge. So now the atoms that we call ions do not have the same number of protons as electrons, and so they will have a net electrical charge. The ion will have a positive charge if it loses electrons. Remember, electrons are negative, so if we're taking away a negative charge, the ion will have a positive charge. If the atom gains electrons, it will form a negative ion because, again, electrons are negatively charged. So every time an atom gains an electron, it becomes more and more negative. Ions that have a negative charge, so those ions that have gained electrons, are called anions. Ions that are positively charged, so ions that have lost electrons, are called cations. So if you have a neutral atom, if it gains electrons, it forms a negative anion. If the neutral atom loses one or more electrons, it will form a positive ion that we call a cation. Another thing is that metal atoms will tend to lose electrons if they have a chemical reaction. They'll tend to lose electrons to form cations, and non-metal atoms will tend to gain electrons to form anions. Remember from your periodic table that metals are those mostly on the left side of our periodic table, whereas nonmetals tend to be on the right side of our periodic table. So these guys over here on the left will tend to form cations, and these guys over on the right will tend to form anions. Now, ions are represented by symbols. The charges are shown as superscripts after the elemental symbol. A plus and negative sign will represent, of course, a positive and negative charge. And if you see an elemental symbol written without a charge, then it's assumed that that is a neutral atom. So here's a couple of examples. Here's the sulfur ion. Sulfur has a -2 charge, so this sulfur atom has gained 2 electrons. Here we have chlorine, which has gained 1 electron, so it has a -1 charge. These are anions, of course. Here we have just an elemental symbol, so we would assume that this carbon atom has the same number of protons as it does electrons. Here we have a couple of cations. Sodium, this sodium cation has a +1 charge, so this sodium ion this sodium atom has lost 1 electron. Here we have a magnesium cation, and it has a +2 charge. So this magnesium atom has lost 2 electrons, hence a +2 charge. So let's look at just a couple more examples. Here we have fluorine. A neutral fluorine atom has an atomic number of 9, so it has 9 protons, and we know that the protons and electrons are the same, so it has 9 electrons. So a neutral sodium atom has no net charge. However, if fluorine gains 1 electron, it's a nonmetal, so it will tend to gain an electron. If it were to gain an electron, Then it would still have 9 protons, but it has 10 electrons if it gains one. And so therefore, it has one more negative charge than it does a positive charge. And so the fluorine ion has a -1 charge, and we would represent the fluorine ion with the symbol F-, indicating that it's fluorine which has gained 1 electron. Let's take a look at one more example. Here we have sodium. The sodium atom has 11 protons, so a sodium atom will have 11 protons, 11 electrons, and no net charge. Sodium is a metal, so if the sodium atom lost an electron, then it would still have 11 protons, but if it lost an electron, it would have 10 electrons. So it has one less negative charge than it does a positive charge. So that would cause sodium, the sodium ion or sodium cation to have a +1 charge. And we would represent sodium, the sodium ion with the symbol Na+, with the superscript plus. Now, you don't have to put +1. If it's just a plus, it's understood to be a +1. So let's try a problem here. Take a look at each of these ions and figure out how many electrons do each of the following ions have. Pause the video and give it a try. Okay, so the first one, we have lithium +1. Now the lithium atom has 3 protons and 3 electrons. The positive charge indicates that it has lost 1 electron. So Li+, or the lithium cation, will have 2 electrons. Oxygen 2-, oxygen has 8 protons, 8 electrons. The -2 charge indicates that it has gained 2 electrons. So the oxygen anion has 10 electrons. Here we have iron 3+. Iron, neutral iron, has 26 protons and 26 electrons. The +3 represents that this iron atom has lost 3 electrons. So 26 minus 3 gives us 23 electrons for this iron cation. Phosphorus 3-, the neutral phosphorus atom has 15 protons and 15 electrons. This phosphorus atom has gained 3 electrons. So if we started with 15 electrons and gained 3, that would tell us that this phosphorus anion has 18 electrons. And barium, barium 2+. The barium atom has 56 protons, 56 electrons, and again, we know all this by looking at our periodic table. This barium ion has lost 2 electrons, and so if we lose 2 electrons, we started with 56 minus 2, this barium cation has 54 electrons. So just one brief little thing about the electron structure, or how electrons are configured in atoms. Electrons, of course, are located around the positively charged nucleus. So atoms have a very small, dense, positively charged nucleus, and the electrons are located around the nucleus. The electrons are not just randomly located, they're located in shells. They exist in shells or specific locations around the nucleus. The further the shells get from the nucleus, the bigger they are and the more electrons they can hold. So each shell can hold a certain number of electrons. The first shell can hold 2, the next one 8, 18, 32, and this will be discussed more detail later in a future chapter. And electrons in the outer shell are held less tightly to the nucleus. So the further electrons get from the nucleus, the less of an attractive force they feel towards the nucleus. So when a metal atom, let's talk about losing electrons for just a minute. When a metal atom loses 1 or more electrons, the electrons are going to be removed from the outermost shell because those are the ones that are held less tightly. They feel a weaker attractive force, of course. The further you get a negative and a positive charge get from each other, the less of an attractive force that they feel. The minimum amount of energy it takes to remove the outermost electron from a neutral atom is called the first ionization energy. So in general, the ionization energy is the amount of energy it takes to remove an electron from a neutral atom. And to pull an electron off of an atom always requires energy. So let's look at a quick example here. Lithium has 3 protons in the nucleus and 3 electrons, 1, 2, 3. The negative and positive charges are attracted to each other, and that's what holds the atom together. In order for an electron to be pulled off or removed, energy must be provided. So if we zap an atom with enough energy, the electrons can absorb some energy, and one of those electrons can get kicked out. In this case here, you can see the electron being kicked out. This would result in a cation being formed. If we remove one electron, then we end up with a +1 cation. So the minimum amount of energy that is required to kick out an electron from a neutral atom is called the ionization energy. One more thing about ionization energy. There's a periodicity to ionization energy. In other words, it follows a periodic trend that you want to be aware of. The ionization energy, the first ionization energy, generally increases as you go across a period. Remember, a period is a horizontal row on the periodic table. So if we start at lithium, beryllium, and go over to boron, oxygen, all the way to neon, it takes more and more energy to remove the first or outermost electron from an atom as we go across. So lithium, it's relatively easy to remove the outermost electron from lithium, but once you get to fluorine or neon, it's much more difficult. That's because as we move across a period, we're adding protons and we're adding electrons. The electrons are going into into the outermost shell. So as we add protons as we go across and we add electrons to the same shell, the electrons get pulled tighter towards the nucleus, so they're held more tightly. So as we move across a period, the electrons are held more tightly, and therefore they require more energy to remove. As we move down a period, the electrons are getting further, so it's going to take less energy to remove an electron as we move down, not a period, but as we move down a group, and as we move across a period, it requires more energy. You can see that also reflected in this table here. Here we have ionization energy, so as we move up, the ionization increases. The ionization energy increases. So here we have lithium, and as we go from lithium, beryllium, boron, carbon, oxygen, all the way up to neon, in general, you can see the ionization energy generally increases. Now, as you go from neon to sodium, you're starting a new period on the periodic table. And also, as you're going from neon to sodium, the electrons are starting into a new shell. Now again, we'll discuss electron configuration in another lecture, but just in general, as you add electrons to the same shell, they get squeezed in tighter towards the nucleus. Once you start a new shell, the electrons move further away, and then it takes less energy to pull that electron off. And then we start that trend again. And adding electrons to the same shell, we end up with higher ionization energy. So be familiar with this, this periodicity or the trend in ionization energy and how that is related to how tightly the electrons are held to the nucleus. So be familiar with some of these trends as well as the general terms and definitions for ions.